Hi, my name is Kabileesh, son of Govindarajoo. Matrix number is 09 DKM 20F2002. Today, I'm going to explain about vector quantities. First, what is vector quantity? Vector quantity is defined as the physical quantity that has both direction as well as magnitude. There are some examples of vector quantities. The first is linear momentum. The second one is acceleration. The third one is displacement. The fourth one is momentum. The fifth one is force. And then the last one is velocity. Now I'm going to explain about the symbol of vector quantity. The symbol of vector quantity is quantity symbol in bold and an arrow sign above. As you can see, there's body. Above that, there's an arrow to represent the vector quantity. Now I'm going to talk about vector representation. First one is magnitude and direction form, where the magnitude is given as a singular quantity and the direction is given via an angle and or the combination of angle. The second form is component form. Component form where the magnitude and the direction are given through component magnitudes in each coordinate direction. Now I'm going to talk about vector in basic. Vectors used in mechanical engineering to represent quantities that have both magnitude and direction. Many engineering quantities such as force, displacement, velocity, and acceleration will need to be represented as vector for analysis. Vector quantities contrast with scalar values such as mass, area, or speed, which have magnitude but no direction. Thank you.
Good morning to my teachers and my fellow friends. My name is VINALESAN RAMAMURTHI from DKM 1A. Is going to talk about scalar. One of the ways in which two vectors can be combined is called a scalar product. When we calculate the scalar product, the two vectors results is called as scalar rather than a vector. So to calculate scalar, there are two ways, communicative and distributive, and the scalar product is Cartesian form. So usually we learn Cartesian form in complex number, but we use it again in our scalar and vector. So these are the questions for communicative and distributive. So as you see, it's given two different type of vector, which is A and B with an angle 60 degrees. Then they will ask us to find the product, the scalar product, which is A times B. So using the formula A times B and modulus of A and modulus of B equals times by cos theta. So it's given the modulus of A equals to 6 and the modulus of B equals to 7. So when we substitute the numbers into the formula, we will get 21, and the scalar product of A and B is 21. So let's see another type of question. These are the type of question we use for Cartesian form. So there's a vector called A with 7i plus 8j, and there's another vector called B 5i minus 2j. So we use the same product, which is A times B, to find scalar product. So when we substitute the numbers, we must times 7i with 5i and 8j with negative 2j. So at the end of the product, we will get 90. So for this question, the scalar product is 90. So that's all for me. Thank you.
What is haunting? What's hard?
Hi guys, I'm SAILESHWAR PILLAI, son of V.RAVINDRAN. My matrix number is 09 DKM 20F 2016. So today I'm here to present about the application of vector and scalar. As you all know, scalar and vector are widely used in various types of fields. For example, navigation of aeroplanes, ships, satellites, gene cloning, computer programming, and physics. It is also used in graphical designing by forming a small pixel and adding them to create a formation of a real object. So let's take a look into one of the field. In gaming, vector and scalar are used to cache the position, direction, and velocities. Let's look into one of the example. As you can see in the picture below, the first picture shows a position vector indicates the man's position 2 meters of east from the origin and 1 meter north. The second picture shows the velocity vector. 1 minute the plane was moved 3 kilometers up to the left. The third picture shows direction vector, which tells us the pistol is pointed to the right. Now let's look into engineering field. Vector and scalar helps to build a navigation system. This system reads the coordinates for the ship, aeroplane, and submarines. In each of this system, there's a device called navigator. So the navigator reads the encrypted code sent by the ground units. So this code will be transformed into a direction that helps the ship, submarine, or aeroplane to move in a safe direction. This also helps to position the ship, submarine, and aeroplane in the radar.
Cross product. Cross product is a binary operation on two vectors in three-dimensional space. Given two linearly independent vectors A and B, the cross product is A cross B is a vector that is perpendicular to both A and B. Thus, it's normal to the plane that containing them. It has many applications in engineering. Cross product should not be confused with the projection product, which is called dot product. If two vectors have the same direction or have the same exact opposite direction from one another, or either one of them has zero length, their cross product will be zero. More generally, the magnitude of the product equals to the area of a parallelogram with the vectors for sides. The cross product is anti-commutative. That means they can switch places. So, for example, A positive A cross positive B become negative B cross positive A. Like the dot product, it depends on the metric of Euclidean space. The product can be generalized in various ways. It can be made independent of orientation by changing the result to an exterior product of vectors. They can use in arbitrary dimensions with two-form result. This picture shows the right hand rule, which is used to find the direction of the cross product. The conclusion. In conclusion, we can now see the applications of vector and scalar in engineering. Vectors are used in engineering to represent the quantities that have both a magnitude and a direction. Vector quantities contrast with scalar quantities such as mass, area, and speed, which have a magnitude but no direction. Moreover, scalar quantities represented by a single number and vector quantities are represented by both a number and a direction. At last, we can now conclude that vector and scalar quantities are applied in engineering to represent position and magnitude. This is because it is often easier to measure things like forces and velocities as a magnitude and direction at, at the start of a problem, and it is often easier to visualize the final result as a magnitude and direction at the end. Thank you.